So welcome everyone. We're really excited for our next Sander Series invited lecture. I have the honor of introducing Saleema today, who we're very excited to have here. So I'll just give you a bit of an introduction and then invite her to the stage. So Saleema is a principal researcher at Microsoft Research AI. She received her PhD from the Department of Computer Science and Engineering from University of Washington, but she has her academic roots in Canada. She did her master's and bachelor's at the University of British Columbia. Now, when we were selecting speakers for Tux this year, we really wanted to get someone who could speak to the intersection between human-computer interaction and AI, and Saleema was someone who came in mind that we should, definitely have. I think what's fantastic about her is that, if you go to almost any HCI or AI machine learning conference, you'll probably see some sessions about the intersection between HCI and AI, but she's been working on this topic long before it was such the hot topic that it is today. Her PhD, which started in 2007, was entitled Designing for Effective End-User Interaction with Machine Learning. So she is one of the true world experts in the field for what is such a sort of timely and relevant topic today. Speaking for myself and personally, we've been working in hybrid interaction experiences where you look for complementing capabilities of humans and machines. Her work has been foundational and inspirational for my own work, so I'm very excited to have her here today. Saleema's research doesn't just stop at sort of designing effective end-user interaction with machine learning and systems. What she's now also doing is exploring how human-AI interaction could be designed in responsible and ethical ways, also very, very timely, and something we'll hear about today. She currently chairs Microsoft's Ether working group on human-AI interaction, which is sort of Microsoft's advisory committee on designing responsible and ethical AI. Her recent work includes leading Microsoft's effort to develop general guidelines for human-AI interaction, which is a unified and validated set of guidelines to establish a foundation for human-AI interaction design. So it's really great to have her here to share that knowledge. From an academic standpoint, she's published extensively. A lot of her work has either been received or been nominated for awards at some of the top venues. And I think what's really unique is she's publishing at a very diverse range of venues spanning both HCI, AI, machine learning, visualization, including Chi, NIPS, AAAI, VAST, CSCW, WIST, IUI, and there's actually more that don't have short, cute acronyms that I won't go through now. But we are really excited to have her here, so please join me in welcoming Saleema to the stage.
Hi, everyone, and thanks, Toby, for that really nice introduction. As Toby said, my name is Saleema Amershi. I am a principal researcher at Microsoft Research AI, and I'm really excited to be here today to talk to you all about why I think planning for failure is necessary for creating responsible AI systems. So this is something I've been thinking about a lot over the years, but also more recently as I've been part of this Ether committee at Microsoft. And so Ether committee is chaired by Eric Horvitz, where some of you might know, has several working groups that focus on specific topic areas. And so I co-chair the working group on human-AI interaction and collaboration. And we're tasked with coming up with best practices and recommendations for creating responsible AI systems. And so we created this committee at Microsoft because, as most of you know, AI is being used in more and more of our everyday applications, and it's being used in more and more high-stakes scenarios, which is fine except for the fact that AI is really fundamentally different than a lot of our traditional computing systems. And that is creating a lot of new challenges for people. And we can see this in, the endless number of news headlines that we see, ranging from humorous AI failures where, you have autocompletion failures or you can't interact with your voice-based assistant, to failures where people can actually get harmed by the AI. And so a couple of examples here is the compass system, which is being used or had been used for legal decision making. And similarly with the semi-autonomous vehicles, where people have gotten harmed if they haven't been able to take over control from an AI system when it failed to detect an object on the road. So in this talk, some of the key things I want to tell you about, I want you to take away, is that a lot of failures are really inherent in AI systems, and many are unavoidable. Also, failures are really socio-technical, not just technical, because they involve people, and AIs are ultimately deployed in the real world and will be interacting with people or impacting people. And so responsible AI really requires anticipating and planning for these failures. Okay, so why do I think, oh, sorry, my PowerPoint is crashing. Okay, let's try this again. Okay. All right. So why do I think thinking about failures in AI is so important? So recently, we started asking people who create and develop these AI systems what their perceptions were about the type of AI failures that we see in the news, the fairness and ethical issues that you hear about in the news. And we heard some interesting and sometimes really alarming responses. So, for example, recently Amazon tried out a recruiting tool, an AI-based recruiting tool that was shown to be biased against women. And so they've since stopped using it. So this is just an example of the type of AI failure cases that we talk to people about. And I wanted to give you a sense of the types of things that we heard. So this is a real quote that we heard. It's representative of a lot of common sentiment that people have. And so a common thing we heard was what we like to call the "this is reality" argument, which goes somewhat like this. There are a lot of people who do not see this as a problem. The attitude is, this is actually what reality looks like. Okay, and so this is really a dangerous sentiment because, even though there is this gender disparity in, the engineering field, it's really incorrect to say that AI models are representing reality. Okay, and that's because all models, by definition, are a simplification of the world, which means that it's difficult, if not impossible, to really fully capture all the complexities of the real world. And so in that case, AIs will make mistakes. So if we look closely at this hiring scenario example, imagine your goal was to build an AI model, a classifier, that could distinguish between people you should hire and people you shouldn't hire. How you represent those people to the AI algorithm really matters. Right, so in this case, you may only have access to a couple of important attributes, like the years of higher education that person has had, or their previous salary. And of course, in this case, you're missing a lot of important information that really will impact whether or not someone would actually be a good employee. Including their ability to collaborate or communicate, or just their life experiences, which are pretty much impossible to fully capture in such an algorithm. And so, your algorithm will try to learn a model in order to make future predictions. But the point is that this is not reality, right? It's very much a simplification of the world. And so it's important to challenge this type of, perception about AI, especially when those AIs are being used in the real world for high-stakes decision-making that may impact people in adverse ways. Okay, so let's hear another common argument, which we heard, which we call the "this is just math" argument, which sounds like this. At the end of the day, the data is just aggregated and shown. It's not going to be wrong what they're going to see. It's still going to be right. We're not expressing opinions or anything. Okay, again, this is not true. And it's quite dangerous this sentiment is quite dangerous because it lends this false sense of credibility to really potentially harmful results. Okay, so going back to my example here, AI algorithms are by design going to make errors, and that's because they're designed to try to do the best under the circumstances. So they'll try to generalize to new data while optimizing some objective function, meaning they're trying to reduce the number of errors or minimize some loss. So all that means is that the AIs are going to sacrifice parts of the input space. So your algorithm might try out this model first, which has 8 errors. Then it might try a different model, like this one, which has only 7 errors. So it will go with this one at the end. But the point is, the way it's designed is that it assumes that there will be errors and it's trying to do the best under the circumstances. Okay, so point again is that AIs will make mistakes. And so even though this is just math, the outcome can still be wrong. And so, ethical AI development really needs to include acknowledging this and work to systematically think about these types of mistakes and try to mitigate them. Okay, one final example of another thing we heard a lot, which is something we call the "there's no problem here" argument, which goes like this. The other thing to note is that there is a lot of talk about machine learning models being biased, right? Is that how you say it? So there's actually no bias in our models just because it's very analytical, okay? So, it's true, algorithms, are math, they're analytical, and maybe your algorithm itself is not encoding any bias, but as we've seen before, how you represent your data, you can still have biases. But even if your model is doing exactly the right thing, this is really sort of a reductionist view of what an AI system is. So an AI system is made up not just of models and data, but it's also made up of the infrastructure in which those models are operating, as well as the interface to people and how they interact with the models in the system. And so errors and problems can occur at any of these sites and result in harms to people. Okay, so take, for example, there's been work recently that has shown that in high-stakes decision-making scenarios, so a lot of AI is being used for clinical decision support or legal decision-making, in these types of scenarios, just providing people with an explanation of why the model is making such a recommendation can influence the person to believe it, even when it's wrong. Even when they didn't agree with it, just the fact that it's providing an explanation can mislead people, right? And so this is something about how we design our interfaces. It's not just something that there's not just a problem with the model. There can be a problem with any part of the system, including the person. We often think of the person as part of the system, as part of this human and AI interaction team. And so problems can occur that can ultimately harm people at any of these sites. And so it's important to think about these systems holistically. Okay, so the point is that it's oftentimes difficult for people to recognize these sociotechnical issues as failures. And I use the term failure really intentionally here because we used to call these issues or problems, but if you don't call it a failure, it often gets deprioritized in the development process, right? Because if it's a failure, you don't ship something that has a failure. And so it's really important to start thinking of these possible errors that these AI systems can make as failures. Even though they're sociotechnical, they're things that can harm people if we don't think about them carefully. And I also wanted to emphasize here that it's not that these people that we talk to don't care, or don't understand what's going on. I think it just reflects this sort of reductionist view of AI as this technical problem. And we really need to start thinking of it as a sociotechnical problem that requires a sociotechnical perspective and an interdisciplinary approach to solving. It also reflects a lot about how AI is taught in schools. So if any of you have taken AI courses, you often will get benchmark data sets to play around with, or you try to optimize some generic metrics. And so there's this focus on just the model and algorithm side, but you miss all of the pain of collecting good data sets and seeing how that model is going to actually operate in the real world. So I think we miss a lot of that experience and learning about how these systems will actually behave. Okay. So this is why it's important to think about failures. They're inherent and a lot of times unavoidable, and we should be thinking about them in a sociotechnical way. Now, when I say here, responsible AI requires anticipating and planning for failures, what I don't mean is that we shouldn't, do our due diligence to advance machine learning and our processes of, training these algorithms and trying to reduce errors or eliminate them in the first place. We should absolutely be doing this. My point is that there are some failures that it's just almost impossible to completely eliminate, and so it's really important to design solutions so that the people who are ultimately going to be interacting with these systems, so that they can intervene or override the AI when it's inevitably wrong. Okay, so how can we start thinking about failures or anticipating these types of common sociotechnical failures? So recently we created these guidelines for human AI interaction. We released them last year. And they prescribe how AI systems should behave as users interact with them. And so we've recently been using the guidelines to try to frame different types of sociotechnical failures at Microsoft and help people think through some of these issues. Now, I won't go into a lot of details about how we created them. You can go to our Chi paper for more of the details, but just to give you a little bit of what we did, we first collected over 150 recommendations coming from academic and industrial sources over the past 20 years, because there has been a lot of work on human AI interaction. We consolidated all of those and then went through 3 rounds of iteration and validation, where we tested the guidelines with real user experience practitioners, so over 60 user experience practitioners, and we had them test 20 AI products, ranging from search systems to navigation, email, just a wide variety of AI systems. And that was really so we ourselves could trust these as a useful tool to think about how to design effective human AI interaction. And so my point here is that we didn't just make these up. We really tried to take a systematic approach to come up with these so that we could use them ourselves. And so you can learn more about them in our corresponding Chi paper if you're interested. Now, so the guidelines here, there's 18 of them, and they can be roughly grouped into 4 categories that you see here, ranging from what you should do initially when a person first starts using the system, to regular interaction with the user, to what should you do when the AI is inevitably wrong, and how the AI system should behave with the user over time. Okay, and so these are rough categories. They're not hard constraints, but we did this to make them somewhat more memorable. But as I said before, we've started to use the guidelines to try to frame this discussion of AI, sociotechnical AI failures. So if I could rename these, what I would likely do is call these first group about how you deal with this expectation mismatches, between what a person expects the AI to be able to do compared to what the AI can actually do. I would call the second set how to deal with contextual mismatches or failures. The third set I would call how to deal with model errors, so the AI model itself. And then the last one I would call how to deal with evolutionary issues. And so this is how I'll group them for the rest of this talk. And so I'm just going to give you a few examples of each of these categories. I won't go into all of them, but just to give you a sense of how they can help think about failures. And I'm going to give you examples from common AI products. So this includes search, which uses a lot of AI features now for things like query processing, ranking results, filtering spam. I'll use examples from voice-based virtual assistants, which also often employ a lot of AI for things like speech processing and task support. Email, so a lot of our email clients now use AI for things like automatically sorting your inbox, or detecting entities in the body of your messages, or automatically generating responses. And finally, social networks that use a lot of AI for filtering your feeds and recommending ads. And so the examples I'll give are actually based on real examples that we collected from our studies, from our original work with the guidelines, because we collected about 700 examples. But I'm showing you in the context, the examples in the context of these fictitious products. Okay, so let's dive into them. So the first category here is really all about setting the right expectations. And setting expectations is really important in AI because people often have unrealistic expectations about AIs because of how they're portrayed in the media and because of the lack of knowledge about how these things work. So if let's look at this in the context of search engines. So recently we had Dan Russell give a talk over at MSR. He's head of user experience at Google Search. And he's done a ton of research on how people search and wrote this book, really interesting book on the joy of search. And so he was talking about, what people believe about search and what they're capable of. And so if you talk to people about, what search is capable of in terms of coverage, a lot of them will say things along the lines of everything is available on the web. And of course that's not true. Not everything. All information in the world is available on the web, but a lot of people think so, and that impacts how they interpret and perceive the results they're getting. In terms of quality, if you ask people how these things work, about a third of people will say use the term magic in explaining how these things work. And of course it's not magic, it's math, but this goes to people's expectations about the quality of the results that they're getting. Right, and so both of these expectations about the capabilities and the quality of the system can really impact how much people trust these AI systems. And I think there's a lot of talk these days about wanting people to trust AIs, but in fact, it can be dangerous to overly trust AI systems. And so you may be thinking, well, this is just search, it's not a big deal. But think about all of the times where people use search. I've been in doctor's offices where, I've been talking about something and then I had a doctor search for, what I'm talking about, get taken to a Wikipedia page and, they're looking at a Wikipedia page, which is, alarming. And so that goes to what people think about what these AI systems are capable of. Okay, so these mismatches I look at as failures, and it can be problematic when people either overestimate or underestimate the capabilities, especially for high-stakes scenarios. Okay, so what can you do? We collected a lot of examples in our original studies, and so we saw a few different patterns for achieving each of these guidelines. I'm going to give you a few here. So first, one thing you can do is provide documentation. Of course, this is something you should use sparingly because nobody looks at documentation. Maybe in high-stakes scenarios they might be incentivized to do so, but not in all cases. And when I say documentation, I don't just mean manuals. It can be even just how you phrase, what the titles you use in your interface. So this is an example from Google, which used to have this title in the news for showing results. And they got a lot of heat when the results that people were seeing were not necessarily from reputable news sources, and so people were misled. And so they've since changed this to, I think, top stories. And so the idea here is that even something as, titles can really help set the right expectations for people. Another pattern that we saw for setting the right expectations was showing people examples of the types of things that these AI systems can do. So here in Bing, if you click on a search field, it will show you a range of possible things that people have searched for, and that gives people a sense of the capabilities and the types of questions they can ask the search system. Another interesting example we saw was, this is in Google. If you ask things like, what's the meaning of life, it'll show you 42 and show you a calculator. And now you know that this thing has a calculator. And so it's about showing introducing people to features at appropriate times, especially when AIs can do a lot of things now and it's hard to list them all. And then finally, another pattern for helping to set expectations is exposing some controls or knobs to the user that they can use to either tailor the AI or interact with the AI. So here we have an example where you can you have all these tabs so people can narrow their search to a different subset of data. And so just exposing that to users that this is a possibility gives them a sense of what the system, the search is capable of. Is it going to be searching, in some subset or like another? Okay. So my point here is that for any of the guidelines, there are many ways that we can implement them. And I think it's also a time for interaction designers and HCI researchers to get creative, right? Because I think there's a lot of new possibilities for achieving some of these, and I think it's a interesting open space. Now, some of you might be thinking, isn't this important for all systems? That's a question we get a lot. I would say yes. So the way we created the guidelines is we selected guidance that was either specific to AI or particularly important or challenging for AI. We also chose guidelines that typically required new solutions that can operate in the face of AI. And because, like I said before, AI is fundamentally different than traditional computing systems. They're complex, they're probabilistic, they operate under uncertainty, so they behave very differently, which means that our techniques for achieving some of these guidelines with traditional systems don't always work. So in this case, for setting expectations, it's actually really hard to provide documentation for AI systems because even for the model developers, it can be hard for them to understand the capabilities of their AI systems because AI systems are designed to be able to generalize and work on new data. So it's particularly difficult, and this is where, again, there's opportunities to come up with new solutions to achieving them. Okay, so we'll jump to the next category, which is all about context. So context is really important in AI because AI systems often make inferences about people and their needs, and those needs depend on the user's immediate environment, as well as the larger social and cultural context in which they're operating. So let's look at this in the context of voice-based virtual assistants. Okay, so imagine you had a voice-based assistant that could proactively send you reminders when they're due. So, maybe your system can remind you to call your mom. So the first two guidelines here are really all about a person's immediate surroundings and thinking about when people will be using your AI systems, especially for proactive systems that can take action without the user requesting them. So in this case, if your system's going to send you notifications, it's really important to think through the scenarios in which your users will likely be interacting with that system. So for example, if your users are likely going to be in a car and their attention is elsewhere, it needs to be elsewhere, then it can be really dangerous to pop up notifications because it can be distracting. Okay, so this is really about understanding the different contexts that people will be using these systems and making sure that your AI itself can infer those contexts. And this means, in this case, that means making sure you're monitoring the right signals. So if you needed to detect the driving context, you have to be tracking the right signals. You have to be able to model that context and then take appropriate actions. Okay, so this is just to say that a lot of these guidelines also can't just be done at the UI layer. It really involves every level of an AI system. So the next two in this category are about the larger social and cultural contexts in which people are operating. And so this is, we have the two guidelines, matching relevant social norms and mitigating social biases. There's actually a ton of work going on around bias and fairness in AI, and there's even conferences devoted to this subject. So I'm not going to go into this in a lot of detail, but I wanted to give an example that we saw in our studies because it highlights how these issues can manifest even in our simple everyday applications where we might not think it would be possible to have biases. And so this is an example where, imagine you were able to ask your virtual assistant, what's the fastest way home? Okay, we actually asked this to our study participants, and in most cases, people said something along the lines of, information is not subject to biases unless users are biased against fastest routes, right? So most people were not able to see a way that this, feature, this AI-based feature, could be biased, except for one of our user study participants said, there's no way to set an average walking speed. The product assumes users to be healthy. Okay, and so, this was like eye-opening to us. Like many of us didn't think about this. And it really highlights the need for involving diverse teams in both the development of these systems as well as testing these systems. Because that's where you can, reveal problems that you may not see otherwise until you deploy a system. And it's important to do that earlier. Okay. So the next category is all about what to do when the AI model inevitably fails. And as I've said before, the AI will fail, they have failures, and if there's one thing I want you to take away from this talk, it's that AI will be wrong. And it's really important to design mechanisms in the interface so people can override or intervene when that happens. So I'll give you a couple of examples. So we'll look at this in the context of email. So a lot of email clients can now sort or filter your inbox based on what it thinks are important emails or not. Okay, so the first two guidelines here, so all the guidelines here are really about specific model errors. So common errors in AI are things like false positives, false negatives, being partially correct. How many people have AI experience here? Show of hands. Okay. So these errors, so like a false positive in this scenario for email filtering would be when the system accidentally puts an email in your important section, which is not important. Okay, it's false positive. False negative would mean when the system misses an important email. Okay. So the point of these guidelines are to encourage designers and developers to think about how these common errors will manifest in their application, and then to estimate the cost to the users for each of those errors. So in this case, it's likely more costly to miss an important email than to be shown an email that's not important, because you can essentially just ignore it. But missing an email is really important. So it's really important that you give people tools to overcome that or fix that when that happens. So in this case, maybe giving people the ability to move their emails around and teach the system. And you'd be surprised at how many AI systems don't give people mechanisms to fix these types of errors. Okay, let's jump to another one. Here, this guideline is about scoping services when in doubt. So this is about, so AIs will operate under uncertainty. If the AI itself is uncertain about something, what this is saying is to do less. Basically, this is like less is more when this AI is uncertain. Okay, so in email, a lot of email clients now can automatically generate responses for you to emails. So here, if someone's asking for setting up a meeting, it can give you a few options of how you might want to respond. Okay, so this pattern of showing multiple options is something we saw a lot of. It's a way of scoping services because, instead of just showing a person the top ranked result, which would be, probably really irritating, if it just showed you one and you only have one option, show people multiple options, right? So that they can actually get the best result. And this, is important, and I think we often overlook these types of things in the industry because there's this desire to often make these things appear as magical. So it's magical if it gets it right, and it does this thing automatically for you and you don't have to do anything. But I think that comes at the expense of people actually getting what they want done. Right, so in this case, it's better to make the system, seem a little bit less magical if you give people the abilities to actually complete their task efficiently. Okay, so these and the other guidelines in this category are all about how to deal with different types of AI model errors. Now, the last category is all about what to do as the user interacts with the AI over time. And this is important in AI because one of the key benefits of AI and machine learning systems are their ability to learn and adapt over time. But it can also be disruptive if it's not done carefully. Okay, so I'll look at this in the context of social networks. So, how many of you use social networks? Okay, we'll see everyone. So how many of you have had this experience where you've been looking at something on your social network feed, and then suddenly you just see more and more of that content, right? Okay, so this happens to me a lot. It's super frustrating, and this happened to me recently where when I made the mistake of looking at this inspirational post from a friend of mine, and then I was just suddenly bombarded with like all of this, sunshine and cheer. And this really happened, and it was really annoying. And I couldn't figure out why it happened. I couldn't make it stop. All my efforts to try to redirect my feed, and I tried to trick it into thinking I liked something else. None of that worked, and it was super frustrating. And so this last set of guidelines helps us think through why this might be happening and how we can sort of prevent it or deal with it. So here, what's happening is that my social network is clearly learning something from my behavior. So maybe I dwelled on this post for too long, or I liked it or interacted with it, and so it learned something, which can be good, but in this case, it learned the wrong thing. Okay. It also updated really quickly. So just almost immediately, I was just shown so much of this content. And so this next guideline, about updating and adapting cautiously, is about thinking through how much to evolve or adapt your AI and at what rate, and thinking about what is best for your particular scenario. The next guideline here, encouraging granular feedback. This is about allowing people to explicitly specify their preferences to AI systems. So a lot of these social networks have the ability to like content. That's an indicator that you might want to see more. But in this case, my social network didn't have an ability to dislike something. So I wasn't able to tell it that I want to see less of this content. And finally, I often actually don't provide feedback to these interactive learning systems like recommender systems, my music recommenders or movie recommenders, because I don't really know what's going to happen when I do, right? And this was the case here. Maybe I interacted with a post, maybe I liked something, and there was no feedback to me about the consequences of doing that. Maybe if it showed me say something like, okay, I'm going to show you more now of this, which we're actually seeing that more and more in some of our applications. Maybe that would have given me a signal about how I should interact with this thing in the future. Okay, so these and all of the other guidelines in this category are about how to deal with these AI systems that change over time. And one thing I want to emphasize is that AIs can change over time, but also people change over time, and people adapt to these systems and change, and their environment changes, and so you have these two systems that might be changing over time, and it's really important then to keep those systems calibrated in some way so people can effectively understand what's happening, and that we give them the right tools and mechanisms to help steer or change these systems to suit their needs. Okay, now this inspirational post example was, a silly example that I'm sure a lot of us have experienced, but I wanted to come back to a more serious example, a very similar example that really happened. So there was an article written by this news reporter, Jillian Brockel, where when she lost her baby, and this was about a year or two ago. And after this, she wrote an open letter to Facebook and Twitter to stop showing her baby-related ads. Okay, so it's a very similar experience, but on a really, difficult subject for her. And she goes on to talk about her experience of, how she tried to make the ads stop, but she couldn't. And since then, Facebook and Twitter have apologized for the incident. But, the problem here is that it's not just like an algorithms problem. It's about like the user being able to do what they want. And so what we can do, so the guidelines can help us think through some of these things perhaps in advance. So again, her system was learning something, so maybe it learned that she became pregnant, but wasn't able to learn that she then had lost her baby. So, it wasn't adapting to the right context. Now, she was able to, she talks about this in the article, so it's really interesting, but she was able to hide a post, like an individual post, but she didn't have a problem with a specific example. She had a problem with that type of post. And so there was no way for her to, again, specify her preferences, so encouraging granular feedback. There wasn't a way for her to do that. There's also a guideline we have here on providing global controls. That's really about allowing people to permanently stop some behavior of the system. And in fact, there is actually a control in some of these social networks to turn off parental ads and other types of content. And she talks again about knowing that existed, but she was unable to find it. Okay, so again, this is about the user experience and giving people the ability to control and effectively interact with their AI systems. Okay, so to summarize, planning for failures is really important for creating responsible AI systems. That's because failures are inherent in AI and they're sociotechnical in nature. And so framing development around anticipating and trying to mitigate these AI failures can help. And so the guidelines are one way we've been trying to do this at Microsoft. But I think it also reveals a lot of new opportunities for ensuring safe, fair, and responsible AI systems. And so, like with the guidelines examples I gave, we had a couple that were about giving explanations about when things are happening. But I think that one of the points I wanted to get across is that there's a lot more we can do. So there's a lot of emphasis right now on interpretability with AI and providing explanations. But I think that's just one way that we can give people the ability to effectively understand and interact with these systems. And I think this is where we can take a multidisciplinary approach, and we need design and user researchers to think of new ways to do this and improve our user experiences. We also have started to think about how we can use these guidelines throughout the AI development process. And so we've written a few articles about this, and this has happened because we initially thought the guidelines would be good for heuristic style evaluation, so just being able to evaluate an existing system. But it turns out that if you actually see a problem with your system and want to fix it, by the time the system and the model is already built, it's really expensive to try to change. And so we're trying to think of ways to bring up this thinking earlier in the design process, and also including it in the creative process so people can use the guidelines for inspiration for new human and AI interaction. We also just gave a tutorial at AAAI about the machine learning and engineering implications of these. So again, a lot of the guidelines you can't implement just at the UI layer. So for example, if you want to provide an explanation to a person, or you need to, then you better use a model that's interpretable to some degree. Otherwise, you can't really generate that explanation. And so you can also, on our website, find this other article that we wrote about the things that we need to think through in terms of the machine learning and infrastructure side of these systems in order to implement any guideline. So I think there's a lot of rich opportunities for coming together across different disciplines to do this. Okay, so with that, thanks for your time, and I can take questions.
Thank you so much for the talk. So we have one microphone there, so if you want to ask a question, you can just line up, and then I can also pass this around if you prefer to just put your hand up, and I can pass this one around. Oh, with that, any questions?
So hi, thanks for the talk. So I'm wondering that a lot of examples that you mentioned are based on discriminative models that you're running some sort of classification task that you're classifying emails or advertisements. And how many of these guidelines that you think that could apply to the context of generative models, where humans are co-create something like music or painting with AI models?
Yeah, that's a good question. So we did focus on like a particular class of AI systems. So classification was a lot of it, but we did look at some natural language systems as well. So definitely, like the guidelines, we intended to be broadly applicable to a class of AI systems which we call sort of AI-infused systems. So you have an AI component that's doing a specific task within a larger system, but there are so many types of AI systems. Like there's more collaborative ones, like you're talking about in like creative spaces where you might be working more with an AI as a team. There's like AI embedded in your environment where a lot of people can be interacting with an AI at the same time. And so we think some of the guidelines will likely be applicable to those scenarios, but you also likely need more guidance for those. So I think it's an open question.
I see. Cool.
Yeah.
Thank you.
Yeah.
Yeah, thank you for the great talk, Saleema. A lot of what you're showing seems to be not totally unidirectional, but it seems to put a lot of onus on the designers to illuminate, to create opportunities for the users to understand more about what's going on. And I wonder how much of the onus needs to be shifted toward the users and the public on through processes that might help facilitate or foster what might be called critical sociotechnical literacy, or rather than simply embedding it within the design process, trying to create larger context within which users and the general public can enhance their knowledge about what's going on about this stuff. So I'm curious to get your take on how much of that balancing act needs to happen.
Yeah, I think that's a great question and a great point. Definitely, a lot of the problems that happen these days are because people don't have the right expectations of these systems. They overly trust them, or they don't trust them enough. I think that will improve naturally over time as people interact with these types of systems more and more. But some of the guidelines that we talk about, and some of the work that we've been doing since then to try to explore different ways of achieving them, I think can help with this to some degree. So for example, we've been diving into this guideline about like how do you convey the consequences of your actions, right? And that's something I don't think we do enough of in these AI systems. And so, if you can like show people the consequences of an action that they're taking, that I think itself can help them learn. And in fact, you'll see there's been work shown that people with a lot of these AI-based systems do spend some time like testing them and playing around with them. So like activity trackers, for example, or Fitbits, they'll like spend some time, testing to see the capabilities of these systems to learn when it's going to work, when it's not going to work. So I think that's another way to sort of help people learn. So people are doing that on their own, but I think there's an opportunity to like make that easier for people. So yeah, I do think like hopefully like it'll get better as people become more literate in AI. But like with some of these, like I consider myself pretty literate in AI, and I still am super frustrated. So I think that does come down to a lot of times like giving people the right controls to interact with these things.
I will ask a question while other people are thinking. We have about 10 minutes, so I do encourage you to think of questions and turn this into a discussion. In terms of using these guidelines for evaluation, so if I've released a system, I want to evaluate it. At any snapshot in time, you might find, okay, I'm great, right? I don't have any of these issues going on, but I guess the problem is some of these issues might sort of be emergent and evolve based on the behavioral patterns and the data that's getting obtained. So there's some new trend in the world, new data gets collected, and that maybe biases things or causes contextual mismatches. So how is a designer, what are the best practices for sort of maintenance of one of these systems?
Yeah. So this is a great question, and I think it's a really sort of exciting problem space. This idea of how do we evaluate these systems, and particularly over time. So in fact, a lot of the techniques that we have in design and user research for evaluation of these systems is really hard to do with AI. So one thing we're looking into is different ways of allowing designers and developers to prototype AI systems. So if people are familiar with Wizard of Oz techniques, so it's actually really hard to do Wizard of Oz with AI systems because it's hard to mimic the behaviors of an AI, particularly to characterize how an AI might fail. So one thing we're looking at is how can we come up with new methodologies and techniques to allow designers to do that early testing of these systems so that they can, before a system gets deployed, see how it might behave. And then another thing we're looking at is this over time issue, right? So it's not just one snapshot, but how do you see the impact of a model update and how that will impact a user over time before you deploy? Because again, it's very hard to do that these days because of this issue of once you only get to see new data once it's deployed, and there's of course been many failures that we've seen when that has happened, Microsoft's Tay, for example, right? It's this Tay chatbot, as many of you might have heard of. Once it was deployed in a few hours, it just turned into this racist chatbot. And so it would be nice to be able to see test some of those things beforehand. And so what are the new methodologies that we need to be able to see that before a system gets put out into the real world? So I think it's a really important problem space that we're not thinking enough about, but we should be.
You talked a few times during your presentation about designers, right, and getting them involved in the process. Mm-hmm. And I'm just wondering if you have any thoughts that you could share around making that work well, because I'm thinking you could have some challenges there with, designers that are trained in one way coming together with the AI team that might be trained and thinking in a different way. Mm-hmm. So if you have anything to share there, that would be great.
Yeah. Yes, this is a great question. It's a problem that's very near and dear to my heart as an HCI person by training. I consider myself an HCI person, but I've been working in this space for a really long time. And it can be difficult to collaborate across those interdisciplinary boundaries. And it's unclear to me how much design and user researchers need to know about AI to effectively work in that space, and how much data scientists and machine learning folks need to know about design. I think that's an open question. It could be supported by coming up with common languages for these people to talk to each other, or boundary objects where they can discuss the capabilities of an AI or what's possible. And there's work going on in that space. But I do think it can be challenging, and it's something that the Ether committee is looking into deeply. How can we bring designers and developers to the table when thinking through how to build these systems? Yeah, it's a great question.
Hi, thank you. So going back a little bit for the data, not specifically the models that can be biased, but also the data that you use for feedback or for fixing your system or for training your system, right? So it's more I think my question is more how do you see that as a person involved in building these things? Yeah. So we know that most of these systems, these new features, are designed and tested in Silicon Valley. And then what we have for IP issues, they are tested on employees, which are white, male predominantly. So how do you see that in your daily work? How do you see that we can go around those IP issues, or all this diversity on the employee demography, to test these features and launch things that were tested and trained with data across a more diverse demography?
Yeah, so that's a great question. So there's a lot of things going on there. So for one, one of the reasons why we want to try to bring these guidelines and just the thinking about the user early on in the process, really to take a user-centered design approach, I think is necessary in the sense that all of the decisions about how you build an AI system, including the data that you use, the models you choose, should be driven by the scenario of use. And a lot of times we'll see sort of a more technologically centered approach where we use what data is available or what models have already been pre-trained and then see where it fits in. But of course, a lot of those times when you have those pre-canned data sets, they're not going to align well to the context that you might be creating an application for. So it goes back to, thinking about the user up front and making sure that you're using that to drive the data collection and the model development process. And then testing, I think there's a lot of work and thinking about how to test. So yes, testing with diverse data sets or diverse people is important. There's also work on tooling to help data scientists and model developers better debug and understand the behaviors of their models. So I think there's a lot of focus in the tools that we have. There's a lot of emphasis on these single score aggregate numbers. So you're trying to optimize for accuracy or something. But really, it's important to, even if your model is doing really well, in the aggregate, it might be doing really poorly on a specific subset of the data. And a lot of the tools that we have don't allow for that sort of slicing and dicing and fine-grained analysis. And so I think that's another way that even if you can't necessarily test with a lot of new people, you can maybe at least explore how it would behave on a certain subset of the population. So that's another aspect. And I think that, and there's also work in the community to come up with better metrics and more human-centered metrics to begin with, right? So instead of just optimizing for accuracy, which hides a lot of the behavior, there's metrics now that have been proposed for fairness, right, or interpretability. And so some of that can be built into the modeling process itself. But there's a lot of questions to be done there because no one really agrees on what the right metric is, and you can't achieve them all at the same time anyways. So again, it goes back to what's the best for your user scenario. Yep.
All right, one more question? Go ahead.
At the start, you mentioned how you had a lot of resistance coming in, it's the data, it's just math.
Yeah.
And then you mentioned that these are techno-societal problems, not just technology. And I just wanted to know from your experiences, how did you go about embedding, or how would you go about embedding that sort of social science or societal knowledge among a primarily STEM workforce that is designing these algorithms?
Yeah, that's a great question. I mean, if I was to think about curriculum that people have, machine learning students have, or data scientists, being exposed to some of those techniques and human centered design courses, I think could help. Another goes back to how we can bring these disciplines to the same table and allow them to learn from each other. But I don't expect that just like we can't expect design and user researchers to learn everything about AI in order to be able to work effectively in this space. And similarly, we can't expect, all data scientists and machine learning folks to know everything about, psychology and sociology. So I think it's an opportunity to come up with new ways for these disciplines to collaborate and understand each other. I think that will help. Yep.
All right, I think we will wrap it up there. So thank you everyone for coming and your attendance, and let's once again thank Saleema for the fantastic presentation.